Evening. How are we all doing? Exactly. A game dev is never late. He arrives precisely when he means to. Now, it's been a week since I streamed last, so kind of need to remember how to do it all. I forget these things quickly. Yeah, don't say Wednesday, you get me confused. I keep thinking it's Wednesday. Oh, hello. One moment. Hello. This is Cheesecake. Yes, we have a cat called Cheesecake. And the reason he's called Cheesecake is because our daughter, when naming her cat, wanted to name it after the thing she loves most, which is cheesecake. Hence the cat is called Cheesecake. So, let's do a quick recap of where we're at, what I've been doing, and all that jazz. So, if you recall from last week, we were building a system whereby we're separating the ship hardware from the ship UIs, and we're having a middleman, which is a layer of servers. And the reason we're moving to this scheme is so that as we roll out more bridge stations, and more stations ship-wide for that matter, including the engineering control room, which is going to be a secondary bridge. There's going to be lots of places around the ship that need to interface with the ship's hardware, either for just reading stats and statistics to actually performing effective actions on that hardware. And we have a situation whereby we're holding a lot of the replication on the endpoints rather than a centralized single source. So we're bloating and inflating the network traffic completely needlessly. And the logic chain for interfacing with the ship's hardware is flawed, basically. So if we get rid of my ugly mug, I'll show you. So we have ship's physical hardware. So we have valves, we have chillers, we have tanks, we've got pumps, all that stuff. This is the physical hardware layer. This is kind of the ground truth for the infrastructure aboard the vessel. Now, some of these things do have UI screens on them, like the valves have got little UIs you can use. And those things will affect the device internally rather than going through the server layer. But the server layer will still be aware of that having been interacted with. What the server does, and the important thing is making these servers ship agnostic, because we want to be able to just put this server on any vessel and have it just work out of the box without having to go and tailor it to be fitting a certain ship. So for that reason, we don't hold any references to any specific bits of hardware. So whereas this particular valve might have the name of that, the server never actually does anything with that name. We rely on the UI and control interfaces to worry about which device we're dealing with. On the server layer, all we're doing on begin place, we do this once, we capture like any tank, any valve, any reactor, and we add all of them to these replicated arrays. And this is where the replication takes place now. So on each client, they'll obviously have a local copy of this server, and the authoritative version of that data obviously comes from the host's version of the server, and this will replicate 5 times a second. So it's not replicating in real time in the same way that a character movement would. We're putting those ticks really, really low so that we're not overloading the network bandwidth with what is essentially just UI data. So because the replication happens here, and not per user interface, it means it's only happening once. So it doesn't matter how many UIs there are around the ship, they're all reading from the same single source of truth. So what we do on the UI's parent blueprint is we query the subsystem and we go through basically the entire array. So if you think about the UI on the bridge, it might need to interface with different hardware to a UI somewhere else. So we've got a UI, say, associated with the engines, and we only care about the specific tanks that are storing coolant for the engines. We would filter that out at this point. So we're saying, okay, so these particular tanks are the ones we care about for, in this case, the reactor. So what we do is we go through, we read what is now replicated data from our subsystem server, and then we update all the UI fields using that replicated data. So we grab a reference to it there, and you'll notice that this doesn't have little white blobs on it, so it's not replicated. So none of the UIs handle any kind of replication at all now. It all comes from this single source of truth. Now conversely, if we're pressing buttons, so this is the player pressing a button on the UI screen, and this is an NPC pressing its button remotely. So again, we want to drive NPC and player actions down the same path so that NPCs and players are both driving the same identical actions. So an NPC says, I want to press that button, and this is what this is. So what we actually do now is, rather than grabbing the device directly, so previously we'd grab a reference to the valve and we would fire the open command on the valve itself. In the new regime, what we're doing is we're actually sending that through to the server via our player controller, so we can make sure it's replicated. So given that the server is host authoritative, clients don't have permission to set replicated variables on that server, so we pass it through player controller first. The command we send is the console command that will be part of the CLI once we add that interface to the UIs. And I wanted to make sure that we kind of prepared for that in advance. So when we actually make the terminal window for the UI screens, we're already sending the commands using that schema. So we have our hardware domain, so that's basically which domain server is responsible for that piece of hardware, the particular hardware type that we're dealing with, and the unique ID for that piece of hardware. So when you're using the terminal interface, it will be automatically populating these values based on where you are within the terminal's directory tree. And obviously, if you were to then type set state open in the terminal, that's the command that it's now filtering on. So when we either press the button or go in the terminal and press enter, it sends the same thing. On our player controller, we simply fire that as a server RPC. So at this point, we're now dealing with that command as the server. We send a message back, so we have a reference to where that message came from, and we tell it to flash the UI button on that interface. Now, by naturally, widget interfaces do not replicate and cannot replicate. So what we're having to do is force them to flash on clients so that when a player presses a button, be it the client or the host, that button flashes for all players. So you'll see which buttons players are pressing, because this is basically saying, you know, I'm the server now, make sure this flashes on all the client host and client machines so that you can see both players and NPCs pressing buttons. Because previously the NPC was just doing stuff, and looking at the UI screen, obviously you can see the information changing, but you can't see that the NPC is actually pressing buttons. So now when they press buttons, you'll see those buttons actually flash briefly to indicate that the NPC has pressed something. And then finally that goes onto the server itself, which is here. And then as the message comes in, we gate that based on the type of hardware it is, and then we just forward that action essentially to the hardware. So here it is arriving on the reactor. So these are the different commands that we could have typed on the CLI, and that's those commands actually doing something on the reactor. Similarly for a valve, it's quite simple really. So we're setting state open or state closed, and all we're doing is setting those variables on the valve. But in order for it to get to this point, it's the subsystem server which is forwarding on the command. It's not coming directly from the user interface anymore. So we've got that middleman channeling messages to and from all of the ship's hardware as a management layer. And I think that's about it really. So it's not quite finished yet. There are a couple of quirks which I need to iron out. The message isn't always arriving, so I just need to work out why. But that aside, this system is like hugely more robust in terms of replication load, client awareness, and general stability. So it's built with replication like hard coded into it, and it's built with network optimization as a priority. So this is going to eventually fix the sensors when I do this on the sensors. So right now this is just being prototyped on the engineering station on the bridge. So when on the next build, when I put it out, everything you do on the engineering station and everything the NPC does on the engineering station is all using this new system. And we'll isolate it to the engineering station until we're ready to roll it out to the rest of the bridge. So we'll do one UI at a time. Sensors is the big one, because the sensors UI is way more in-depth and involved than perhaps it needs to be. But the replication side is really, really heavy, and we're sending a lot of traffic over the wire, which I think we can cut down on quite significantly. In a multiplayer environment, when you go between sensor modes, there's a noticeable delay on clients. It causes quite a hitch and doesn't always update the UI, and that's because of just how much replicated data is being pushed across to all the client machines. If we are instead managing our single source of truth here on the subsystem server, then that's no longer the case. And rather than tanks and valves and reactors and all the other bits of hardware we'll add to this, instead you'll have sensor arrays. So we'll need to add those sensor arrays as physical hardware, and we'll start tracking the state and the output of those arrays using this same methodology. So it doesn't matter whether you're using the bridge sensors, whether you're using the sensors down on sea deck somewhere, or whatever sensor station around the ship you happen to be using, it's all reading from the same source. And we can also use it for queuing up jobs as well. So if the sensors are being used on the bridge for something, and you want to use them for something else, say down on sea deck, then there might be a queue situation where you need to wait for that particular module to stop its current action before you can then do an action using that same physical array. So we can start building that kind of complexity into the system more easily by handling it like this. So yeah, and there was one more point I wanted to make. Yes, and NPCs. So obviously having all of this managed using a central subsystem server means we have queryable states for any device on the vessel. And obviously the subsystems are attached to the main ship computer, and the main ship computer isn't actually doing anything yet. It's just sat there as a placeholder. But the main ship computer will then also start querying the subsystems to work out whether or not any alarms need to be raised for any particular device. So if the reactor is about to overheat, for example, the main computer will alert the Ava system. So Ava, as the ship's AI, will be her own subsystem essentially attached to the main computer. So the main computer will say to Ava, reactor's about to overheat, you need to make some announcements, and that will trigger Ava initiating some kind of a warning message. And similarly, the NPC, again, now that the UIs are pulling from this replicated data, the NPC will see on the screen in front of them, because we're tying the NPC to the screen when they're using it, so that they are sort of seeing the screen. We're kind of injecting the information into the NPC, but we're kind of simulating them seeing the screen. They'll be able to quickly turn around and say, oh, we're about to run out of fuel. So they'll announce that to the bridge, which is handy because at the moment they don't. They just happily ignore the fact the ship's running out of fuel. So all the different things that we need to do are all dependent on this new system. And it's going to make life very much better across the board. Right, and I think that was everything. So I'll stop waffling now, and we'll get on to doing a bit more shuttle work. Good, glad you're following. So on last Sunday's stream, this is where we left the shuttle. I went ahead and changed the colour of a few things so I could take some screenshots. But yeah, this is essentially where we're at with it. So there's a few tweaks I need to make to the outside, but we won't worry about them too much at the moment. This little beak it has at the front here, that will go away once we combine the two halves together. The way subdivision works is it kind of smooths and pulls on all the various vertices, and because this is two separate meshes just lined up against one another, it gives you this kind of pointiness. So when it's all one mesh, that will naturally pull and smooth across. But what it won't do is fix. Can't really see it. You can get it at the right angle, kind of like here. You can see that it kind of goes in and out. It looks a bit like a bum. So we need to smooth off these corner pieces here so that it comes in more smoothly to a point and doesn't have kind of these sticky out bits. But again, that's kind of a final polish more than anything. I think the next priority really is going to be getting the outer and inner skin joined for the window frame, the same as we've done here. So get all that solidified around there, and then work out what we're actually doing at the back. So, you know, which bits are sticking out, which bits are going to be part of the hull. You know, is this going to pull out beyond the door frame? So we've just got a few design decisions to make there, and then maybe smooth this off a bit more, and yeah, a few bits and pieces just to do. And then once we've got the smooth metalwork itself done, then we'll start looking at hull plating on top of it. So this is literally just the base skin. Things like the heat shields and everything will go on top of that. Is that pinched? I thought that was pinched along there, but no, that seems all right. Okay, so let's unsubdivide stuff. You can see the chin, yeah. You can see the chin kind of there, the way it just comes in that little bit. So I'll smooth all that off. Right then, I guess we'll do the back first, because I know this is going to be a nightmare around here. So I'll put the nightmare off until later, and yeah, we can sort out how we're going to do the back. I think I will use non-subdivided modeling for all the engine stuff, and just use subdivision for the frame that goes around it. Yeah, so we kind of need to pull out that edge without grabbing all that. Yeah, so we give ourselves like an extra little edge there. And then we'll have the outer hull section slightly proud of the door section. And then we just need to make sure that we build our door geometry so that it actually closes properly. So we'll need a lip so that it can seal against space, and then we'll need some kind of a hinge under here so that it can open smoothly, again whilst sealing solid. So I think one of those like banana shaped hinges, yeah, so when it opens there'll be a slight gap there, but at least when it closes there'll be a solid seal all the way around. Yeah, the two seats in the airlock we might not have room for, because we need engineering maintenance panels and things for the engines. So we need to be able to take this panel off in order to get to that, which means we can't really have it be a seat. But yeah, we'll refine that as we go, because I'm sure that we'll have to make some bits bigger and some bits smaller, and once we start working out exactly which bits of hardware we need, then we'll work out whether we've got room for it. And actually on that note, I think while we're doing this back section, let's add a few bits of the physical infrastructure too, because that'll be quite interesting to see. Yeah, because we need commodity tanks for the engines, the main engines, and commodity tanks for the RCS. Now technically the RCS and the main engines use the same inert gas. Now whether we use the argon or something else, they can just share a tank, because the main engines are essentially just bigger versions of the RCS ports. They all use the same tech, which is a Vasmir rocket. Yeah, so if we make tanks inside the wing, or essentially the wing is the tank, the same as an airplane would be. Then we do need to kind of double skin that a little bit. Yeah, we can just make the engine fit the space we've got there, that's fine. And then we need to work out exactly where we're going to put the RCS ports. Obviously we've got plenty of room in the nose for tanks and other hardware, but we're definitely going to need RCS somewhere around the nose. Guessing I'll probably have an up thruster maybe here, either side. And we could potentially put one going that way, but needs to have to not interfere with the wing. I mean, we could do a wing-mounted RCS, maybe. It will interfere with the airflow, though. If we were going to make that a lifting body, the way we were planning. Ideally, I guess we don't want our heat shield to be too interrupted with RCS ports. Yeah, we can have one either side for both braking thrusters and forward-facing RCS. So again, with our center of mass that we were playing with on the last stream, the main engines need to be aligned with the center of mass of the ship, which needs to be here. So the forward thrusters, which will have poke out of here somewhere, also need to align with the ship's center of mass, which means that the RCS thrusters need to be placed around that center of mass. So it doesn't matter if the forwards and backwards engines are offset anywhere along, at any distance away from the center of mass horizontally, they just can't be away from it vertically. Let's grab that out of that group, pop it in its own group, and then we'll start treating this as our hardware layer, because we also need to think about power aboard the vessel. The engines are electric, so the question is, are we generating power via a small reactor, in which case that might have to live here in the nose, or are we lining the underside with batteries and having the thing be battery powered, which means it would have to be rechargeable from the ship and via a solar array if need be. We need to do that volume per wattage calculation. We do have it written down somewhere. I need to dig that back out again. We worked out how big the volume of plasma needs to be per bit of generated power that we need. So we need to run that calculation against the shuttle to see whether or not the reactor would be small enough in order to provide the power that these engines will realistically need. Just grab that from that side. Okay, put them in the same group. That's now our hardware group. And if we then put that there a minute. Make that a component. Put a copy of it there. Put that one there. Actually, it needs to be in that group, doesn't it? Right, now we can work on it in isolation over here without needing to worry about all that geometry. Yeah, I'm sure it's there somewhere in my giant scratch pad of information that I have written down. That is a component, that's helpful. Yeah, so we need to scale that down a bit. easier if I do it on this side. Kind of needs to be there-ish. Yeah, so if our forward thruster is going to be there, then that means we're going to have to do something with this. So if we just hide that for a minute. Yeah, we're going to have to mold some kind of RCS port into the geometry here. And obviously the lower we put the center of mass, the lower we have to not just move these engines down, but the lower we have to move this down as well. So we might have to do something like that. Just move that down a tad, just to make room for that port. And then mold that geometry around that shape. In fact, if we bring that thing back a minute, that gives me an idea. So right now that's 9 centimeters in radius. So if we carry that forward a minute, then we'll work out how much of a hole that needs to be made. So obviously we need to cut an oval into this surface to make room for what will be a cylindrical port on the front there. Yeah, so this is going to go over one of our loops, which is never fun. So ideally, it could all take place limited to this part of the geometry, but it's not going to. It's going to go over it. So that's going to be a minor imbotherance, but we will deal with it. Yeah, so we're going to have what is essentially an oval there, and obviously this is the kind of thing we're going to have to sort out to make sure it's a smooth oval with a solid back to it, a flat back, so that we can then actually build the thruster itself within that hull. Which we'll probably do as a separate object, but we need to make the sort of a smooth hole for it to go in. so one of the things that we, I guess, need to nail now is where we're putting the center of mass vertically, because the moment we move these down, like the moment we do that, obviously that's going to adjust the geometry that we need to cut here. I think definitely rather avoid coming across this loop if we can. That's purely from a lazy modeling perspective. So the initial center of mass was there. If we lower it ever so slightly to like there, I would just record where that is. So and the midpoint along that line would be the ship's center of mass, which would be there. So that's our center of mass that we would calculate for the engine. Again, this isn't the center of mass that's calculated by the physics engine. It's a center of mass that we specifically set manually because of the way Unreal calculates its center of mass based on its collision primitives. We basically can't rely on Unreal to pick a balanced center of mass. It's always offset to some extent. So if we set our own center of mass manually, then we know that it's always going to be perfect in terms of engine alignment and all the rest of it. So so you can quite rightly call it a fake center of mass, but it's one that works. So I'm happy to fake it if it works. Yeah, I've never used Houdini. I would certainly be interested to try it, but it's about whether or not it can do the architectural stuff that we need it to do. Yeah, okay, so I mean, as center of masses go, it's not terribly unrealistic, although I think I would move that back a bit. So obviously the bulk of the ship's mass is kind of more at the back, so maybe if we line it up with that edge. Again, where we put the center of mass along this line is irrelevant to these engines, but it'll make a big difference to the RCS. So wherever we position the RCS, the center of mass needs to be ideally exactly between them for the best balance. And then we can adjust we can adjust the handling of any particular vessel just by tweaking where the center of mass is. So if we want something to be kind of bum heavy, all we need to do is just move this back slightly, and then we can have it perform that way. But we'll eyeball that kind of per ship. Yeah, I think that'll do us for that. Right, and then when it comes to this, this is too many edges for the subdivision, so we shall give it a smaller number of segments. What should we give it? Let's give it 16. Because remember, we're subdividing this, so that'll each one of these will become 2, which will become 4. So that's actually 60. So this 16 edge cylinder will become a 64 edge cylinder when it's been subdivided twice. So we just kind of need to bear that in mind. And I think for simplicity's sake, if we offset that by 2 maybe, and then we'll subdivide that again. That might have been a little bit too much, but we'll see what it looks like. See, these edges here are quite sharp and they're offset. Yeah, they're offset by 2, so that should give us a reasonably sharp edge. Okay, now the fun part. Yeah, it's more about practice, I suppose. Been doing SketchUp for so many years now, I'm just kind of, I just know it. Okay, so that's an easy one to smooth off there. And we're going to have to do a bit of tweaking with this as we go. None of these inner edges are needed, so we can get a shot with them. And then we need to kind of reconstruct this face. See, that's awkward. There's little bits like this where we've intersected. We just need to make sure we clean those bits up. Same there. Don't need to split that face the way we are. Let's see whether or not we can stretch a face over that. Another question I get asked a lot actually is why don't we use parameterized modeling? And I guess my answer to that is yes, I'd be interested to try it, but I don't really know where to start, so I have to look into that, find the best tool for it, and see whether or not I can do the same kind of workflows that I'm used to with parameterized modeling instead. Obviously that does give you more tweakability. It's not quite so destructive. I can already tell this is going to create some nasty pinching. We'll try and automatically detect the edge loop, but I know it will fail because there are too many split edges. So I'll just try that and just see, out of interest, can I skin it in a way that doesn't do that? Nope. No, manual it is. going to need fixing there as well. So this is naturally going to produce garbage, so we shall have to clean all those edges up and work out where our triangulation needs to be converted into quads. I think those ones should be all right. Yeah, that's going to be an awkward one. I think we will just cheat there a little bit. Yeah, so part of the issue there is that we're trying to preserve the geometry flow coming down through here. So if we were to guess maybe drawing that up and that up there. Yeah, and that needs bridging across there because that's no good. It's going to leave us with one triangle there somewhere. Okay, so yeah, we could do with just bringing that in slightly. Yeah, the rest of it's not terrible. Just that bit there I'm not quite happy with. needs just pulling in, but that is essentially an RCS opening. So what we would do is model an actual thruster to go in that hole, but we'll sleeve it, so this is the base metal underneath, and we'll do like a heat tile sleeve that goes around there. This is all going to be white paneling on this side anyway, so we'll have a black surrounding panel, kind of NASA style, around there, and then build all that thruster geometry in the tube, and then obviously that needs to align with the actual hardware on the inside, and those become our braking thrusters on the edge there. And then in a nice way, that's kind of in line with our center of mass there. We're almost braking exactly on the center of mass, which is kind of serendipitous. Okay, I can see what's happening here. So all we need to do really, if we can just bring that forward a bit like that. In fact, bring both of them forward a bit. Should fix that weird pull on that edge. Yeah, that's better. It's much more rounded now. Okay, we have our first RCS hole. Hurrah! Thank you, Delta. And I'll leave the back off of it, obviously, because we're going to insert geometry into there. Right, so now we know where the hole is. Let's add just a temporary thruster nozzle, just so that we've got like a baseline to work on. So we want that to be mirrored. Well, that's clearly too big. Right, that's more like it. And yeah, I agree. You get much nicer results, obviously, with subdivision, and it's much easier to make adjustments after the fact, but it can be a right mare to work with. Have that just like cheekily poking through there. May as well try and seal this back up actually while we're here. So let's reverse these faces because they point us in the wrong direction. Probably worth moving that over a bit. We shall fix this minor nightmare as well. Actually, I think I was just lifting that up, wasn't I? So we need to repair that curve around there at some point. Yeah, because what we were doing, we took the shape of the outer skin, but of course we want the inner skin to be a lot more flat and organised. So we need to kind of reconcile some of these edges and get rid of some of these kind of nasty bumpy bits. But we'll do the back first. Actually no, we can't do that because that's going to mess up the edge flow, so we're going to have to do that. Similar issue there, really. I could do with a supporting edge going down the middle just to align with that, or get rid of that. Yeah, why do we even have that? So obviously these two halves are going to be joined together, so we don't necessarily need to worry about joining up on this side, because or joining with the geometry on the other side. Yeah, then we could do with another loop down there really, but that's going to bite us the closer we get to this point. See how we get on with this. So that would be a quad, and that would be a quad. And that would be stuck as a triangle. That makes more logical sense. And then that stuck as a triangle. Guess we also need an inner edge on that as well. I'll see what it looks like. I'll forget that face for a minute. Yes, that definitely needs to be sharper. Yeah, really, it's more kind of design-wise. What are we going for with the back of the ship? Because we definitely want that back bit to be indented. I think having this lip around here is needed. Yeah, then we need to work out where our center of rotation is going to be for the hinge for the door. And then we obviously need to build that geometry in there, which can form whatever we're doing around the back. I'm also going to need a couple of little RCS ports around here somewhere too. Guess we'll maybe stick a couple on the outside of here. Yes. Yeah, so all of these seats will just fold down. So if you stow the seats back, then that essentially turns this into cargo space. So it's kind of multi-purpose. People or cargo on a per seat basis. So I guess we need some like some cargo ties on the floor as well. So if you do have cargo, at least you can like tie it down. What did I move? Oh, of course, that didn't inherit the movement I did over here. That's fine, I'll fix that afterwards. As long as this one's lined up, that's all that matters. Right, let's try and get that door sorted. So height-wise, it's 177.5 centimeters, which isn't really high enough. We want the opening to be 2 meters. And that's 2 meters once we've added floor plating and all the rest of the internal gubbins to make sure that we maintain the headroom of at least 2 meters wherever we are walking. So this door frame and probably that one need to be lifted up slightly. Right, let's make the ramp. Actually, did I hide the ramp? No. I'll make a new ramp. Actually, I won't explode those just yet. Right. So if we follow the logic that we're using for the main ships, then what we generally have is the main cavity between decks, which is what this is under here, where we store whatever we need to store. And then where we have the interior walkable space, we have a slight underfloor cavity where we make room for things like the artificial gravity coils and things which are part of the floor tile. That's another bit of hardware we need, actually, the artificial gravity generator. So we've iterated on what is generating the artificial gravity quite a few times, looking for something which is scientifically plausible and within the bounds of the amount of power we can generate. It's a difficult one, because what we don't want is, if we were to use the same tech that we use for the FTL drive, which is an element which greatly increases the mass energy equivalence principle, so that you need far less energy for the same amount of mass, which means that you're generating a gravitational effect with far less energy input. So for things like the FTL drive, where it needs to compress space, you're driving that effect with less input power. So if we want to do the same thing for artificial gravity, we would need to be driving that same amount of energy literally through the floors where people are walking around, which just seems like a recipe for fried crew members. So what we did instead is we decided that we'll have a single field generator and an element which reacts to that field to create a gravitational-like effect. So it's not actually gravity, it's something that has a similar effect to gravity. So it has that same kind of pull on matter around it, but it's more akin to magnetism than gravity per se. We haven't fully gone into the specifics of it yet, but kind of that's the ballpark we're aiming at. So we'll have this mesh-like material that, when energized, basically sucks things towards it in a gravity-like way, which means we need a generator that energizes that mesh. So we create a field around the ship, and any of those sort of gravity meshes within that field are energized, but it's harmless to humans. So the fact that the field exists doesn't mean you're getting electrocuted the whole time. But it does mean that we need that on the ship here. So we build it into the floor panel. So each floor tile that we're screwing down to the floor has that material incorporated inside of it. So as soon as the field is energized, that particular floor panel is now sucking things towards it. So we need to make sure we definitely have enough room for that on the floor tiles. And we need to define obviously how big those floor panels are going to be. And then we need to work out where the attachment points are going to be for those floor pieces as well. So once we know that will tell us what our vertical height actually is once we've got floor panels and indeed ceiling panels actually in place. So maybe we should do that before we do the door. Otherwise we're going to be working on incomplete numbers. Okay, so just as an for instance, let's say that's our floor panel, then that would be 1 inch thick if we were using the same ones that the Magellan's using. It looks really chunky on here, but yeah, once you see that like in VR, you realize that it is in fact just 1 inch, and it's not as thick as it looks. Then we can perhaps take it down to 2 centimeters, given that we are on the shuttle. I suppose we need, in some ways, some customization on the shuttle as well. So if you want like a carpeted shuttle, then we can certainly go that way, or have kind of rubber floors or whatever. Now I'm exactly as thick as I look. Yeah, so if we were to extend this out to the edge of the bracing, yeah, then I think I would be actually tempted to line these up and have a bunch of horizontal panels. Yeah, just have them laid in strips. We'll see. It depends if we put anything in the floor, because if we need to lift that panel off for any reason, we might need access to the cavity in the floor. Okay. So I guess we don't need to worry about the ceiling tiles when it comes to the doors, because they're below that level anyway. So really, obviously again, the ceiling tiles would, at the very least, be equal in height to that, because that's the the internal bracing where we'll put the brackets and stuff. So let's say we had a ceiling panel with lighting and everything else on it, so that would be anywhere along there. It's not interfering with the door frame. And then that would have to be at minimum 200 tall, which means these would have to be at minimum also 200 tall. Wait a minute. Oh wow, that's all the way up there. Huh. That might require a bit of fudging to make this thing a bit bigger. I think she must be quite short. Hang on, let's work out what is 6 foot in centimeters. 182.88. So if we draw a line, 182.88, like that is a 6 foot tall person. Wow, she's really short. So if we measure to the top of her head, and then we grab our tape measure and we type in 182.88, then it will resize her to be 6 foot tall. And as you can see, she cannot traverse that doorway. So where did she go? Well, that's weird. That's better. Let's try that again. 182.88. Okay. Right, it's more like it. So the obvious choice really is, rather than messing with the overall height of the shuttle, we instead just change the scale of the shuttle, just to scale it up ever so slightly. Probably better off doing that using the exterior mesh. We just pop her there a minute. so we designed the interior that you could stand upright all the way basically to the seats, at which point you're scraping your head just as you're about to sit down, which means you can walk between the chairs but no further. But height-wise, that doesn't look terrible there. Guess it doesn't need to come up far. So that's 182. Right, if we make it 190 then, just so that we've got room. So we do 190 on there. That takes us up to there. Yeah, so we're really sort of pushing the framework, making it quite thin. So I think what I'd be tempted to do is literally just make the shuttle bigger, like wholesale. So if we were to grab all of that, so that would be 10% bigger, which is too much bigger. So if we do 1% bigger, so we haven't made it like significantly larger. So like this hasn't grown significantly. This back down to our base point. Make sure we're still aligned as well. Yeah, that extra 1% has just given us a bit more clearance at the top there. Means width-wise the shuttle is now just over 5 meters wide, and tip to tip it's going to be in the region of 7 meters long. So it's bigger, but not like hugely bigger. And then we've got 1.9 meters worth of clearance in our doorway, which is hopefully enough for the tallest ever character. We will have to do the same inside as well. So again, assuming a floor panel height of 2 centimeters. That would be a ducking situation, so again we will move that height up. To the. Yeah, so we're going to have to be kind of careful with how thick our ceiling panels are, because they're going to be going pretty much to the ceiling. The doors, rather, are going to be going to the ceiling. Wondering whether we maybe bring that down ever so slightly to 185 rather than 190. So 5 puts it there. So that makes that, yeah, exactly 185. So again, a 6-foot person is 182.88. So that is enough for a 6-foot person to clearly be able to walk through. Well, being that I'm 6 foot myself, I always have to be accommodated. Yeah, the idea with the shuttle was to make it as compact as possible within its mission profile. We didn't want it to grow too large to the point where it would struggle to fit in the likes of the Caravella. No, the internal frames would not have scaled, but that's fine because we need to redraw these anyway. We need to draw the frames off of the subdivided version because the subdivided version will have much smoother slopes on the inside, smoother curves. So we'll draw the frames off of the smoother curve, not the jaggedy one. But yeah, so 185 centimeters I think is probably the sweet spot. The doors on the Magellan are all 2 meters tall, so they offer plenty of clearance headwise. Okay. So I guess really we can probably get rid of yeah, if we get rid of these frames, and we know the height for there anyway, we'll keep, no, we'll get rid of those ones. We'll stick the floors in, and then we'll draw some new frames post subdivision. But what we really need to do is work out again that hinge geometry at the back, because that's going to define kind of how far the back of it sticks out. If we grab a copy of that, stick it on there for so we can copy it over their reasons. Okay. So make sure we are in the right place. Actually, that needs to go over there, doesn't it? That one. Yeah, so conforming to our inner lip, that would come out like that. And then if we grab that edge, then we can make that inner frame again. Now we'll just grab a copy of the inner frame, and then we can delete the old one. Messed up there somewhere. Was that it? Oh no, it was just SketchUp being SketchUp. Right, so that's the back door with the new slightly increased scale. So what we need to decide is how thick the door is going to be. Obviously we want it to fold down flat to the floor, so we'll do a slightly wedge shape on the bottom there. And it needs to have like a grippy surface because it's going to be a slope. And then we'll have a lip running around the outside so that it seals tight. Two new tutorials should hopefully be ready, I don't know, I guess another week or so. I need to just finish off the fuel side of refueling with the NPCs, just to make sure that the NPCs are consistently refueling the ship and not just ignoring it while it runs out of fuel. Once we're there, then the tutorials are very much next on my list. Especially because we've had an influx of new backers recently, and new people are joining whilst the tutorials aren't working, which is not a great situation. So we definitely need to fix that. So we need a seal that we can do around the door. And I guess if we're doing a floor panel that comes up above that, so the floor panel is going to be, let's say, there at a minimum. So floor panel. Let's pop her back down at floor level. Okay, so she's still got headroom. Right, so this basically needs to fit that gap there. Oh, hang on, the axes are all messed up on that. What's going on there? So the complicated part of this is we need to rotate this from about here-ish. So if we say, I guess maybe down to there. So what's that? So it's 2 centimeters there. Let's say 2 there. Oh. Well, that's no good. Let's see, how much did we just lose? Ooh, that's quite a long autosave, that's annoying. Let's pre-scale. Hey, autosaves. I think that might have crashed either during the autosave or just before. Huh. So we wanted it to be 1.01 bigger, so that was our 1% that we worked out. Okay. Oh, at least we've still got our thruster port. That would have been an annoying thing to have to do again. Right, so then just make sure we are still aligned to there. Her again. I think it must have crashed right before we did the scaling with this mesh. Okay, so we'll do this as a group so that it doesn't go all weird on us. So we know that she has to be 182.88 centimeters tall, which is exactly 6 feet. Yep, and then she needs, or rather the door needs adjusting so that she'll fit through it. And then we said we'd do 185 for the door frame height. So we'll just grab that edge there. Line that up to our 185 meter stick. So that's restored that to where it should be, and then we'll redraw that edge again. Yeah, then we'll have the floor intersect with wherever the door closes. Probably Delta, yeah. It really depends on how big those spacesuit helmets are. We don't want them to be too huge. I saw, can't remember what series it was of what. Hang on. I saw some nice ones which I thought were quite good. It might have been the SpaceX one actually. Oh yeah, because Jared Isaacman did that canopy opening, didn't he? Because they were testing the suit and the door on the Dragon capsule. Oh yeah, there it is. Yeah, so that's the SpaceX pressure suit, which is reasonably nicely form hugging, and it's not terribly bulky. So I've got a better picture of it. A picture of Jared looking all boss. Yeah, so it doesn't need to be like a massively bulky suit. Obviously it's going to have some kind of backpack arrangement, but helmet wise I think this is perfectly good. Try and find a picture of one with the helmet closed. Something like that. So yeah, we don't need to be too tall when it comes to that. Oh, it happens, serious. Yeah, the amount of times SketchUp has just abandoned all of its work on me. I just deal with it and roll on. Roll with the punches, as they say. Yeah, well, the thing is, now that I've scaled the shuttle, we've actually got a fair bit more room above that we can kind of go up into if we need to. Let's just see what we actually have on this side once we grab the edge. Interestingly, that should have lined up there. Which tells me that something isn't quite lined up. So that should be exactly lined up with that. Yeah, and it wasn't. It was almost lined up, just not quite lined up. earth is going on there? What's happened is one of these vertices has gone astray ever so slightly. Yeah, that one and that one. Yeah, they're off by a tiny amount, but SketchUp still sees them as coplanar because they are so offset by such a tiny fraction. But we just need to make sure they're on the same plane, and then we should be able to create a face. It's better. Right, so that's going to be our frame. Yeah, and that also includes the floor, of course. And then door, it's 185 above that. If we wanted to go taller than that and go 190, that would be that. And I can't remember how wide we were going to do them. Meter and a half. 75 there, 150 there. Yeah, so it's already a fairly substantial doorway. Actually, let's separate out that from that. And then we had a curve of 20, 1, 2, 3, 4, 5, 6. So we'll double the amount of edges on that. So grab that corner and that corner. We'll say an offset of 20 with, let's give it 10 faces, make it a smoother curve. So that would be our opening at the back of the shuttle. And then of course we need to create the lip. So if we select that edge, create the offset. Okay, so if that's the lip on the outside, and the floor tiles are 2 centimeters thick on the inside. Then what that ends up giving us is actually a flush entrance. So we'd have rubber floors or carpet or whatever material we choose with the customization for the flooring tile, and it will be flush with the edge of this as you go in. So yeah, then we need to make the door hinge, which is where we got to when it crashed. So if we grab that edge again, like so, copy that, pop it back, and create a face. And then extrude that to there. That's the inside. Stick it out a bit more on the outside. Right, so that's basically a flush close with an overlapping lip to make it airtight. Save that now that we are about to do it again. So overwrite that. Yes, all good. Thank you, Melissa. We decided to spend the week really focusing on getting some code tasks done, and not getting distracted by things like working on the shuttle, because otherwise I spend a week thinking about it. Yeah, so if we make that the point of rotation, then what we end up with is kind of that. So it would kind of come down like that and then seal solid in the hole. But when open, it does mean that would create a gap, which is perhaps not ideal. Although that said, actually, that is kind of covered by that lip, so it's not necessarily a terrible gap. Yeah, because the lip there kind of saves you from falling down it. How wide is it specifically? 2 inches, yeah. So basically that's a 2-inch gap, which isn't the end of the world. Yeah, the probe room and the shuttle bay are very much different rooms. I'll give you a very, very quick demonstration. If I can find my way around the ship. So the shuttle bay is here at the back of the ship. Yep, fix that. So the shuttle bay has its own little observation room. Obviously this will be made much nicer with much bigger windows, and we'll have things for controlling the doors and stuff up here. So this is like the shuttle bay control room. You'll have lots of maintenance stuff down the sides. There'll be a shuttle 3D printer in here somewhere. Cargo handling, refueling, all the stuff you'd expect from like a working flight deck. That all goes at the back in the flight deck. The probe room is actually upstairs. So if we were to go upstairs up here, the probe room's on the other side of this wall. So if we follow the corridor around, this takes you into the probe room. So this is a completely separate room that's dedicated just for handling probes and dealing with the probes when they come back. So we will actually have like a holding zone here for all the stuff that you offload from the probes, and then the NPCs will grab those things from here and then carry them off to whatever lab. So say there's stuff that needs in here, and each lab has got its own storage room. So general idea is probe goes away, probe comes back with new thing gets put in the staging area, NPC takes thing from staging area, takes it to the lab storage room, and then science is performed on it, and then that's that thing adding to your science quota. Whereas if you want to go somewhere, then you have to come down the stairs and come around here and go down these stairs and come around here through what will be an airlock into the shuttle bay. So yes, they're very different spaces. It's amazing how far our shuttle's evolved from this stupid little thing to that stupid little thing. Basically, yes. Yeah, the whole idea of a probe is you send it down to a planetary surface and it comes back with something. You'll configure each probe for a specific purpose, so you'll configure it with an oceanography package if you're sending it to an ocean target. You'll send it to like a geology package if you want to get some rocks. So you'll be able to send it off to get a specific thing, and it will come back with that specific class of object. So if you want to do a lot of work on geology specifically, then you'll just send geology probes. I guess where that's probably more useful is if you're trying to unlock an alien language, then you'll be wanting to send it down specifically looking for samples of that alien culture so that the ship's computer can unlock its language for you. Me too. I can't wait to get it properly flyable. This is going to be good. Yeah, so we're going to have some kind of like hinge mechanism, like a bar hinge that goes all the way across, to rotate that. And then the question is whether or not we have it closer to there, because we have to move it like 0.5 there and 0.5 there, then our center of rotation is closer to the ship. Let's just pop that in that group a minute. So rotating from there, you're basically rotating around a closer point. So when it's open, that 2-inch gap is now another ½ centimeter closer to the vessel. And that lines up with that perfectly, actually. So yeah, so we'll have to build the back of the ship here with that hinging mechanism kind of in mind. So I guess we need a motor or something underneath here that drives that. Again, all electrical. Science gameplay. It's difficult to say exactly when we're going to do that because there is so much stuff generally that needs doing. I would say probably once we've got the sublight stuff done, then we'll look at the science stuff, because getting the sublight stuff done is in some ways more important because it's what unlocks being able to leave the ship. Once we've got the shuttle working and sublight engines working, then we're really in a position where we can get out there and explore beyond the confines of the vessel, which is what we want. Actually, if I attach that there, let's assume them to be attached. We'll beef those up a little bit, but that's kind of the general idea. Yeah, I'm going to put a few of those along that run. So as you're stepping in and out of the ship, you'll see the mechanism there for opening and closing the door. It won't just like magically open and close. It does actually have some hardware associated with it. Yes, this will be the boarding ramp. Big enough that you can roll cargo and stuff into the shuttle. We do need that lip there though, so let's just work out where ground is going to be. It will be very airtight, so the seal around here will be designed to make sure that this fits flush and forms an airtight seal. We'll widen this geometry as well and have some kind of clamping mechanism to make sure that it stays that way. Yeah, so when we do our final door, we will slice off a bit of that top piece so that it forms less of a lip when it touches the ground. Obviously we'll do that once we've worked out what the landing leg height will be, then we can tune that accordingly. For now, let's just get the door closed again. Yeah, I think these need to be much beefier. They look a bit small and pathetic there. Let's get that door end thickened as well. So control-wise, we'll have a panel on the back and also a panel on the inside, I guess on the inside wall there. So you'll be able to just walk up to the back, open it with a keypad. We'll do a lock code on the keypad as well, the same as we do with the other doors. So you'll be able to obviously lock the shuttle when you leave. Yeah, the issue with having the entire back of it open is that we lose the ability to do things like put control panels on them. Also, structurally, I think it's nice to have structural framework around it. Also, then it would be a weird shape. You'd have like the curved edges would be quite pronounced when it was open. I think I definitely prefer nice kind of straight flat edges to the ramp. Yeah, don't leave your shuttle unlocked. Oh, I see what you mean. Yeah, well, we could do that, but I think I prefer it straight. Yeah, so we'd have a walkable surface, kind of like that. Oh, I forgot to turn off Discord notifications. Apology, everyone, that was mine. And it was Delta that pinged me, so you can all blame Delta for the ping. He was just sending me a picture of this. That's a chunky boy, that one. Yeah, it'd be nice to see the mechanism underneath there. Like how is it actually moving? Is that, well, I'm guessing it's manually done, so I'm guessing there's like just normal hinges, and one of the tank crew would actually physically do this. I doubt that's automated. But yeah, interesting. Okay, so it does do it on its own. Very cool. I'm going to separate out the frame from that. And then we'll copy that 50 times 12. Yeah, so that's what the internal frame is basically going to look like, except obviously it's going to need adjustment. Like these internal faces, where we've extruded the outer skin, we've lost that specifically set separation distance. So each frame is supposed to be 0.5 meter apart, but like these ones are offset, so they'll all need bringing back into line as our final kind of tweak and polish when we do that. This is true, yes. In a space environment, when you've got vacuum, that's definitely going to be a factor. Yeah, well, eventually we're planning to have lots of different shuttles for lots of different purposes. Like this first one that we're making is literally just not so much a troop transport, a crew transport. So we're just building something that is purely for ferrying people around. That's it. It's his only job. Take crew members and ferry them somewhere. And you know, when the seats are folded up, you've got limited cargo space as well. It's like a van or a car. It doesn't really serve any purpose beyond that. When we have things like the mining shuttle or the mining vehicle, that's going to have storage bins for raw resources. It's going to have some kind of mining drill on it. It's going to be much more industrial looking, like a JCB in space, basically. It has a set job to do, so we need to make sure that every shuttle, every vehicle we create is created for a purpose. And the design of that vehicle will be with that purpose in mind. So this one being a small personal transport as such, it's designed that way. A cargo vessel would be bigger and probably less refined, because this one, when it's done, will have kind of nice curved control panels and wooden trim, and should look, you know, kind of nice on the inside. Speaking of, why don't we give that a whirl a minute? Yes, we know what our frame widths are, so that should be practically 150. Give or take the width of that. Yeah, so that edge should be lined up to there. Okay, so that should be in line with the door frame. And then, because these are 1 centimeter wide little bracey bits, I need to move that across by exactly 0.5. Yeah, and then of course, so we've thickened this up, and we're gonna have to thicken it even more because you know, that's way too skinny for making, you know, a decent outer door. So it's probably easier if we move the whole thing back a bit. Because if we're using that as our baseline there, because I don't want to kind of break the 50 centimeter rule when it comes to the internal framing. So what we can do is maybe move that back maybe another 2 centimeters. We're still kind of dealing with the edge we've got there, so there's still plenty of room. Okay, then this one has to come out to there and then half again. And then this one would be 0.5 that way. Right, it's looking a bit better. And then we'll also make this indentation a bit wider as well for the door. So if we pull that out, just remember that I've moved it 100 centimeters, so I can move it back the same. And then we'll just widen that a bit. Actually, where's the middle? Yeah, there. There you go, that's better. Much more substantial framework. And then we can start kind of rounding bits of that off as we need to. And then fixing whatever's gone wrong here. Okay, I'll have a look. Let's see if I can play this without sound. Apparently I can't. And now I can't stop it. Stop playing. There we go. Now it's muted. No, it's not. Okay. Interesting. Yeah, so that hinges from below, so yeah, as long as we leave clearance around it, then it should pass the lip. Now, let's just move that back a minute. Yeah, so the one in the example there, it was hinged at the bottom. See, that is sealing on the inner face. Like, even if we leave it slightly ajar, like, as it's closing, as long as there's clearance to the inner lip, then that should seal. And obviously we'll put like a rubber seal around it as well on both sides. And then we just need some kind of some kind of mechanism to hold it tight at the top as well. Yeah, because once that's in place like that, then we are completely sealed all the way around. Yeah, I see what you're saying. That the point of leverage is at the bottom. So if this is turning, yeah, I won't watch it on stream because it's someone else's video. I'll look at it after the stream. But yeah, so obviously the point of leverage and the point of force is at the bottom here. And as you work up the geometry, obviously this bit up here is having much less force put on it than this bit down here. But as long as there's something up here which pulls the door tight and clamps it, then it should be sealed all the way around. I've seen a video on those people that are like when they've been doing work on the sea bottom and they have to be in those chambers for like a week to slowly decompress, and then like a door opens a crack. It's not great, but it is only 1 bar of pressure, unlike like the deep sea things. They undergo much bigger pressures. Just poured water on myself. So the point of rotation has to match that bit there. So in actual fact, we are slightly too high. Yeah, thank you. Yeah, so really this needs to be somewhat more substantial. So if we were to have, say, that. Yeah, I mean that looks better. The other thing we can do is we can do something like that, or maybe even higher than that. To be honest, even higher than that. So from somewhere up there. little bar looks pathetic now, so that can go. Yeah, feels better. Yeah, I remember watching a video yonks ago about ballpoint pens and how they were like the pinnacle of engineering. Yeah, so I think what we'll have is obviously the main motorized hinge point being here, which handles the initial closing of the door, and then we'll have some kind of mechanism at the top here which rotates to force the top closed. So obviously if we're pushing up here, then we're pushing on the pivot that's down here, so the whole thing top to bottom will be squeezed in as we squeeze the top of the door, which means we'll need something up here somewhere that just kind of rotates around. Yeah, so I guess the process will be door closes, rotator thing there goes zzz, and just holds it in place. Sealing it as well, so you can't push it open from the inside at that point either. Right, then our floor panel should open, go up to there, that edge, and that edge should be exactly equal to that line, which it is, so that's good. So that's our actual frame geometry, which means the next frame will be lined with that one. So we need to make sure that the geometry on the back here kind of leaves a gap and makes room for I guess the motor which is going to turn this. Yeah, so it's going to need some kind of motor housing on the outside for that. Well, we'll leave that detail for later. Can do. Let me just measure that gap again now that we've made some adjustments. Yeah, so as we open, like if we assume legs, maybe about there. So with the landing gear on as well, you're probably looking at a ramp, kind of like that, which means you are going to have this gap here. We'll adjust this as necessary so it doesn't collide. Yeah, so the internal flooring will be flush with the frame, but yeah, you will be left with this gap. We can contain the spindle within something, so really the only two gaps will be where the hinges are, and then we'll just have something across there. Obviously it can't ever come up further than this lip, because this is where the seal will go. In fact, if we model that real quick. Does that grab the whole thing? Yeah. Okay, so we'll just pull that out. So halfway would be there. So if we do that to there. .5 to there, 0.5 to there. Right, and then move that out a little bit. Group that up. Yeah, so we'd basically have a rubber seal on the inside and then a corresponding rubber seal on this side. And if we have them so they're kind of like separate and like they kind of go into each other like that, then you've got that seal, which means this one will probably have to be thinner. Yeah, so if I just copy that a minute, and then we'll just put the door back. And then paste that there, which means it should have appeared on here. That was in the wrong place then. I think that means the door is also in the wrong place. Oh yeah, it is. So yeah, so we need to make sure we move that geometry up. So that, and that. Turn that off. Soften that off. Yeah, so that. And all of that needs thickening to there. Right, that should be the right place on there now. So I'm going to take a copy of that. Move that out of the way. Right, so very simplistically, that thin strip there would fit inside that groove. Come on, camera, you can do it. Yeah, that will fit inside that groove there. So when the door is pushed tight, you've got that airtight seal. I guess the only thing I can think of that would cause issues with that is obviously, you know, during normal operation and, you know, the door's open and you're on a planetary surface and it's, I don't like the moon or Mars, and it's really dusty, then you're going to get loads of dust and crap going in this groove, which would significantly reduce its effectiveness at forming a seal. But yeah, there's only so far you can go with it, isn't there? With it being a game and all. And then we'll make this some kind of an attractive grippy pad to walk on. Right, I think we've got ourselves a door. So the next thing is, well, I think before we do kind of like the finalized layout of the internals, let's again continue what we were doing with the hardware, because things like this are now the wrong scale to match what we did with the ship. So let's just scale those at 1.01. Hopefully that will now fit the whole-ish. That's better. shall just open this for now. We need to make sure we adjust our center of mass to match the center of thrust along there. Yeah, we were 0.5 centimeter off, so that just needed refining. Okay, so the engines then are going to need a chiller for recycling the gas back to liquid form, because they're going to be storing liquid fuel, but it's cryogenic liquid fuel. So it definitely needs a chiller device. Now we've got room enough under the floor for that, but we definitely need to be able to get to that stuff for maintenance reasons. If something breaks on the ship, then you need to be able to fix it mid-flight, so lots of maintenance hatches. And I will just open up this face again so that we can get inside it all. Actually, let's reset the colours on that as well so we can see what we're doing a bit better. Yeah, see, I'm tempted to do a fuel tank within the wing as opposed to make the wing itself a fuel tank. So we'll give it a second skin for that, because if we're doing like a cutaway render, it'll be nice to be able to see the fuel tank. Because eventually we want to be able to, like we do with the main ship, be able to turn off all the geometry and just show the hardware, which would be kind of nice to see. Yeah, so we'll probably have like a single, maybe a single pump for plasma injection there. Because whether or not we're firing forward or backwards on this engine, it's either or. You're never going to be firing forwards and backwards at the same time, because these are the braking thrusters there, and these are the main thrusters for moving forwards. So it's going to be either or in this scenario, so they can share some infrastructure. The other RCS thrusters, however, they'll need kind of their own stuff. Let's just kind of rough it in a little bit. Yeah, I think we definitely need the ability to remove the floor tiles, absolutely, and get to the stuff underneath. So when we position the hardware, we need to make sure we bear that in mind and position hardware in places where you can get to it. So we'll have some kind of fuel pump there. We're going to need a coolant loop around the engine. So we'll have pump in, and then we'll have that return to the chiller out. So we're going to need a chiller as well. So let's just rough that in a minute. And if we use that as our mirror. We copy that face and then extrude that out a bit. This is just very rough for now. Okay, and then we scale that down uniformly. Basically, we create a tank which kind of hugs that inner space there, but we're going to have to split that for fuel and coolant. Actually, let's measure it properly, just for good measure. So if we go from one side to the other, we divide that by, say, 3. Then we want this part of the tank to be coolant. So we just make a small gap there, like so. So copy them. Intersect those. Okay, so basically that's fuel and coolant tanks. Obviously we need to mold them to shape and smooth them off of everything, but that's the basic gist of it. Let's give them some colours. Let's say that colour for the argon. And say that one for the helium. Right, so each of these two tanks is going to require a pump associated with it. Yeah, and these are the things which we need to be able to get to from in here. Now what we could do is make these tanks supply all of the ship, all of the thrusters and everything, rather than just these ones. So what we can do is kind of make them bigger across here, and then we can have like a maintenance shelf there with the pumps and chillers on, which means we'd have all the thrusters and things on this side with all this hardware, and then all this side with this hardware. So we've got kind of physical redundancy, and maybe have it so that we can fail over to another pump if we need to. Okay, that does mean, therefore, if we come across to, say, there. I guess we don't want to go too far because we also need to worry about our door opening hardware. So maybe about there. Yeah, and then we'll extend the tank under there. So these are going to be weirdly shaped tanks, but kind of needs must. Have a good one, Jim. Good to see you as always. Well, the nice thing about doing it like this is that the tanks are equally spaced. Well, they're mirrored either side, which is good, and they go pretty much the length of the shuttle. So weight-wise, you're holding all the weight kind of in a balanced way. Yes, it does make, again, the ship slightly top-heavy, but not overly so, I wouldn't have said. We're going to have a bunch of stuff in the nose as well, so that will probably balance that out. I'll just join these up for now. This is very rough, so it doesn't need to be exact. It's just to kind of get the general kind of idea of the shape more than anything else, just so we can see what kind of space that's going to take up. Same with this one. Keep that off to one side as well, so we can see what we're doing with it. So yeah, so the general idea is that we have the fuel and coolant tanks basically using up all the space in our little stubby wings like that, and then pump hardware, chillers and all that sort of stuff can occupy this cavity where the engines are, and then we'll need to supply those commodities to the RCS as well. I guess if we're dedicating all of these rear bits for the engines, I guess life support can go in the nose, because we've got this really nice big cavity behind the consoles, so it would be good if like oxygen tanks and things were all stored up front where they are, I guess, out of the way of all this stuff. And of course that's going to offset the center of mass as well, so it kind of balances it out. So let's say I guess if we do it from here. Yeah, so we can have a nice big oxygen tank at the front. We'll move that back a bit because we're going to have to make some room for the RCS around there. So the RCS thrusters in the front, in the nose, they're just going to have to take their commodities from the back, so we need pipe work running underneath. But yeah, so we'll make that oxygen. And the CO2 scrubber hardware can go in there as well. Yeah, and we're going to use that stuff they use on submarines, the amine stuff. Hang on. Trying to find the right word. I don't think it's methylamine. It was a longer word than that. Can't find the exact word, but yeah, amine scrubbing. Ah, that was it. Monoethanolamine. Yes, thank you. Yes, so we're using monoethanolamine scrubbing, where we use that chemical to strip CO2 out of the atmosphere, and then we just boil it off, and we can dump it overboard as gas. So we're constantly, scrubbing out CO2. but then obviously we need to inject oxygen into the system, so we'll just have an oxygen tank stuffed away in the nose here to do that. And let's rotate that around. Hopefully that's a big enough tank. The shuttles will have their own short-range sensors. They just won't have the same kind of long-range capability that the main ship has, because the shuttles are very much not FTL capable. They're literally designed for pootling around atmosphere and around orbit, like low orbit around a planet. So like you wouldn't really even take one from the planet to the moon unless you wanted to spend a long time doing it. Okay, so having done that, we would need some kind of platform. Basically like a utilities tray of a sort. Certainly move that back a bit more, make a bit more room. So yeah, so this will obviously be split into framework pieces, which means it will have things like lightning holes cut through it, and it'll be through those holes that a lot of this stuff will need to be positioned. I might actually model them in now so we know what we're dealing with. Oh, good night CSI, have a good one. Because of the way this starts to pull in, I'm going to have to do this basically frame by frame. Yeah, actually, if we do it from this one, no, not that one. Where's our actual frame. Yeah, that one. Actually, there's an easier way of doing that. While I think of it. So yeah, if we take this face and do that, then for each one, just intersect them with the model. Oops. Now, obviously, I will need to do this again when we do the actual proper subdivided mesh, because we'll want to do it with the smooth subdivided geometry and not the pre-subdivided geometry. I'm hoping I can, yeah, I can just cut out the bit from we don't want. Probably easier if we do that over here, actually. So the important bit is doing the like the internal ribbing around here, because we need to use this internal cavity to create the support structure for things like the engines. Right, so we don't care about those bits. Hopefully that's picked all them off. Let's just join up the middle. So we can see how the geometry isn't quite lined up, so I'll need to just tweak all these vertices so that they line up with the 50 centimeter frame lines, because otherwise when it starts doing the geometry properly we're going to end up with weird misaligned cuts, which we don't want. And you can see throughout the length of the shuttle that gap gets worse and worse and worse, so we'll just pull all that in so that it's not quite so misaligned. Yeah, that would make sense actually. Yeah, having the underside of the wings removable, or maybe just the back section so they slide out, because I guess we need to create like a surface within there. So yeah, for each one of these sections we would need to do something like that. Actually, these sections will define the tank shape far better than what I've done so far, so I shall quickly redraw those as well. Right, so we'll go all the way forward with it. So we're not taking advantage of the full space that we have, so we can definitely do that. This one's going to need fiddling with. Yeah, so when it comes to like this bit, we really want, I guess, circular sections cut through. I mean, that's like the back, isn't it? So yeah, we can have that tank poking out a little bit. Yeah, so I guess the tank hole, because if that's our mechanism there for the hinge, then I guess we need to just define where that's going to be there. Okay, so that would be the gap that the tank goes through. And then also we need to make sure we've got enough room for that shelf. So in actual fact, it would have to be more like that. going to component this up so I can edit it up there out the way. Because what we wanted was this bit here. Because we want to make that slightly bigger by about that. And then do something like that. That will fit the mounts for the engines, and also the hardware as well. Then that's going to need more room, so let's bring that down a bit. Yeah, it would be nice if the tank was such that it could just slide out if you were replacing it, but it's an awkward one because of this shape here. Of these weird faces a minute. So at the very least, the tank would be that. And obviously it's separated out into the sections we've got. And then we'll like round it off and stuff. Yeah, the question becomes where do we draw the line in terms of where the tank kind of fits over here. I mean, we could always maybe just take that edge and use that. this one. Where's that join? Ah, there. Obviously not all of them are lining up properly, but we can fix that over here. Yeah, but the idea is that the tanks will fit inside of the bracing like that. And then to some extent down below as well. But the question is then, how do we deal with the hardware? Because obviously that needs to fit too. Yeah, for sure. Okay, and on those ones, we just extend those as well. Oops, not the whole thing. So that's going to need its own tiny little hole going through there. But yeah, so on the inside of the shuttle, obviously we need maintenance hatches here. So these three sections correspond to the three sections before we have the internal door, which means this airlock section is also our kind of maintenance bay. So I guess we need three small hatches on the inner edge to access the hardware that's behind it. I suppose the hardware doesn't need to be flat, does it? It can be at an angle. I mean, that might solve the problem. Because if the hardware was mounted diagonally like that, I guess it's easier to see because it's facing you more from the inside, and that gives room for these tanks to fit across there as well. So that tank go across there like that. Which means that that would have to go over there. there a bit. Yeah, like that. And then actually let's measure that slope. .8. Yeah, near enough. Yeah, these are the bits I like as well. It's like doing all the hardware and the internal wiring and all that stuff. Really kind of turning this into an actual vehicle as opposed to just a concept piece. And then working out obviously what it needs and why. Although SketchUp doesn't always behave. What I'll do actually, if we have a face that we can align to, that would make that easier. Sometimes the only thing you can do with this is delete the face and start again. There we go. Now it works. And that goes up like that, which means we don't need that. Caesar, thank you. Yeah, I definitely think Claire needs some chocolate. Same again here. Let's fix this face because SketchUp's being SketchUp. And we can get rid of all this gubbins in here. That will need restoring as well. Yeah, so I guess something somewhat like that, and then the tanks can align to these bits here, and then up to those bits there, and the same across there. Yeah, there we go. So tanks are aligned inside the stubby little wings, and the framework will just go around them like that. And then we create ourselves, make sure I'm not in that group, and then yeah, here across the middle bit, we will create a maintenance, or rather a hardware shelf, like that. And then we mount our physical hardware onto this shelf. Yeah, so that's where our fuel pumps, our chillers and all that stuff, we can put all that hardware on here and then make that accessible through the hatch and the maintenance bay in the back, and that gives us our kind of in-flight repair capability within the game. Okay, well I think we shall leave it there, looking at the time. Definitely been some geeky stuff tonight, which is always good. Good, sounds good to me. All right, well, have a good, what day is it? Oh, it's Sunday, isn't it? Yes, so have a good week ahead, everyone. And I shall see you on Wednesday, where we shall be doing more of the same. And we'll start really deep diving the hardware aspect of the shuttle, just to make sure that we've got enough room for everything and we're not trying to squeeze it in after the fact. But yeah, that should be fun. All right, see you on Wednesday, everyone. Bye for now.